Okay. So okay. So now let's see how to assign, how to give excitation using lump port. Okay. To assign a lump port. Okay. So we have to give the excitation to this one, and this one, and this port. So we have to give 4 excitation. Okay. So normally we are giving the excitation from ground plane to uh, the microstrip site. Okay. From ground to the line. Okay. Normally that is the normal procedure. Okay. So to give the excitation, okay, we can't give the excitation uh, uh, directly. We have to use a rectangle. Okay, we have to use a sheet here. Okay, okay, we have to use a sheet here. Okay, as we have draw the rectangle for the copper part, we have to draw a rectangle to give the excitation also. Okay, otherwise excitation we can't design the excitation. Okay, so I have to draw a rectangle here. Okay, so this is our uh, first port. This is second port, third, fourth port. Okay, so I will give the excitation uh, in that uh, direction. Okay, in that way. Okay, otherwise our S parameters, our name will be changed. Okay, because this is 1 and this is 2, 3, 4. So I have given, this is our first, I have to give the first excitation here, second excitation here, third one here, fourth one here. That is why I asked you to mark the rectangle when we are uh, when we are uh, when we are drawing this transmission line. Okay. So if we can remember this, it is easy. Now we have to find that because we forget to mark it. No. Okay. So I think as I can remember, rectangle 4, we have assigned for port 1, rectangle 4. Okay. Uh, it's not highlighted. So this is our ground plane. Okay. So this is our microstrip site. Okay. This is not, we can't see them because it is united. No? Okay. So we have all, we can see all this section. Okay. Okay. So anyway, um, anyway, so you can remember that this is our first port and this is our second port. So I will give the excitation to the first port. Okay. So before giving the excitation, I have draw a rectangle. Okay, rectangle. So that rectangle should be touch. This is strip and ground. Okay, then I can give that ground to line excitation. Okay, so I have mm, draw the I have to draw the rectangle from here to here. Okay, from here to here in this side. Okay, so so here you can see the plane. Okay, so previously we have drawn all the object in xy plane. Okay, but if we draw the rectangle in xy place, we can't put it here. No, so what it should be? It should be so this is xy plane. Okay, and it should be YZ plane. No, it should be YZ plane. So I have to change the plane to YZ. Okay, So now I hope we can draw a rectangle. Okay. So I draw the rectangle from here to here, like this. Okay. So I have to, I have to, uh, I have to make this rectangle nicely fit with this transmission line and with the ground. Okay. So uh, so we have to find the coordinate for this rectangle also. Okay. uh, so you can see that. Okay. So the x coordinate is -10 for this port. Okay. So I will go to my design again. Okay. So again we have to use this one. Okay. So this is our x coordinate, that is -10, and y coordinate will be 5.6. Okay, y coordinate also will be 5.6. So that coordinate will not be changed, no? That is same. Okay. So I put that coordinate for this rectangle 8. Okay, so this is the rectangle. So I put that coordinate to rectangle 8. Okay, so the position, x position is -10. The y position is 5.6, 5.6, and I keep x position as z position as 0. Okay, so if I okay this, okay, okay this, okay, so now you can see that it is moved. Okay, it is moved. Actually it is moved because of this. We haven't, still we haven't give the z value. Okay, z value. So what is the z value actually? So z should be, this is the thickness of the substrate, no? Z value should be thickness of the substrate. So it will be 0.762. That is the thickness. Okay. So I give it as, okay. So I give Z size, okay. That is okay. 0.762. Yeah, it is already assigned. Okay. And okay, so we have to put it here. Okay, we have to put it here. So what is this direction? This is y direction. No, you can see that here. You can see the coordinate, and this direction is the y direction. Okay. Now we have put, so here the rectangle. This is our rectangle. No, so this is -10 and 5.6, and y direction, y size is -1.55. So it is minus. So that means it is drawn in this way. Okay, in minus side. This is the minus side. No, this way minus side. Okay, so if we have given plus 1.8, that means to this way, I think it will be fitted. Okay, so let's given that one. So likewise, you have to think, and you have to fit that rectangle. Okay, that is very simple. Okay, you have to know the x, y, z coordinate. Okay, so you can see that now it is fitted, no? Fitted. And this is nicely fit with this area, and also this transmission line section and ground plane is also touched with this rectangle. Okay, so now we can give the excitation. To give the excitation, we have to create this rectangle. Okay, we have to select this rectangle. Okay, we have to select this rectangle, rectangle 8, and we have to right click on it. Okay, then you have assign excitation, assign excitation using the lump port. Okay, And this is the resistor. You can put it as 50 ohm because transmission lines are normally 50 ohms. Okay. So next, here you have no any excitation. Okay. So you have to give a new line here, select a new line here. Okay. Then you have to give the excitation. So this is our ground side, ground plane side. So now I click there and I give and I draw a line to this way. Okay. And I drop it. So you can see that it is defined. So now the excitation is defined. Okay. So I next finish. Okay. So for here, I have given excitation properly. Okay. So when I given the excitation, it is already here. It is already, it is mentioned here. It is shown here. Okay. So if I click this, so this is our excitation. So this is our port one. Okay. This is our port one. Okay. Now we have to give the excitation to the port 2. That is, this should be our second excitation. So this will be the port 2, no? This will be the port 2. Okay, so this is the port 2. So in the same manner, we have to draw a rectangle here and we have to put the position also here. Okay, so we will try to do this. Okay, so so I get a rectangle here. Sorry, now we have to. Okay, so this is our. This is port 1 and this will be port 2. Okay, this will be port 2. This is port 2. Okay, and we have to draw rectangle here. So I get the rectangle and I draw it here. Okay, here. Okay, like this. Okay, so I have to give the required uh, required coordinate and the length. Okay, so you can see that this point. Okay, so that is this point. Okay, so this port. Okay, so we are going to give the excitation here. Okay, so you can see that this point, for this point, x value will be 26.04. That is x value. Okay, and uh, the y value will be this, no, that is 5.6. So y value will be 5.6. 5.6. Okay, and z value should be uh, so this is the z line. Okay, so z value should be we are going to draw it in z direction, no? Okay, so z line, z value should be, z position should be what is the z position? It should be 0. Okay, maybe we will check. Okay, uh, when we are drawing the rectangle, we can get idea. Okay, so if I right click here, if I double click here. Okay, so this is our rectangle. Okay, now already x value are okay, x value are okay, and uh, y value is should be 5.6. No, it should be 5.6. 5.6. Okay, so I put it as 5.6. Okay, 5.6. Okay, and the z value. Okay, so this is the z coordinate. No, this is the z coordinate. So if I put z 0 and the Z sides is to 0.72, I think it will be okay. Okay, because now this is the Z line. Okay, so this is Y and this is X. Okay, so now we are, so if I go it here, okay, I think you can understand. Okay, so this is Y and this is X. Okay, now this is Z. Okay, now let's say like this is Y and this is Z. Okay, and this is X. Okay, now we have given X and Y coordinate. X and Y coordinate. Okay, X and Y coordinate. We have to draw our rectangle in YZ plane. Okay, YZ plane. Okay, so so we have given the X value. Okay, that is 26.4. Okay, so this is X value 26.4 and Y value, that is 5.6. Okay, so we have a plane. Okay, so we have YZ plane we are going to draw. Okay, so we have a rectangle like this. Okay, and it is shifted to here like this. Okay, so this is the Z. So this is the Z value. So Z value will fit with the material thickness, not material thickness, dielectric thickness. No, so this will be the dielectric thickness. So that will be 0.062. Okay, so if I put this Z as 0 and Z value as 0.762, it will be okay. No, it will be okay. It will be nicely fit. Okay, so you have to think in 3D dimension. Okay, I think I'm right. Okay, let's see. Okay, so I put this Z as 0. Okay, and the Z value should be 0.762. Okay, and Y size should be 1.8. No, one Y size should be 1.8. Correct? Yeah. Let's see. So I think a rectangle nicely fixed. No, it is okay. Okay, so now we can give the excitation. Okay, now it is fixed with this. You can see that we fix with this transmission line and with the uh, ground plate also nicely. No, okay. Now we have to give the excitation to that one. We have to select this rectangle line. I click on it, assign excitation, lump port. Next, then we have to draw a new line. Okay, then this is the ground plane, this side is ground plane, and this side is, so it is defined. Okay, finish. So this will be our excitation 2. Okay, that is for port 2. Okay, okay. Okay, so we have given excitation here and we have given excitation here. So excitation 1 is here. You can see it is highlighted. This is port 1, and excitation 2 is here. That is port 2. And we have to give the third excitation to the third port. Okay, so this port. Okay, so we can use the same procedure. Okay, so this is the port. Okay, so as usual, I will draw a rectangle from here to here. Okay, from here to here. Okay, so that one you have x direction, x value that is 20.26.04. Okay, this point x value is 26.04. Y value is this value 21.2. Okay, 21.2, 21.2. And in the same way, we will put z dash 0. Okay, z dash 0, because here we are going to go in yz direction, yz plane. Okay, and we have x value that is 26.04, and we have y coordinate that is 0.4, that is 0.4, sorry, 21.2, that is here. Now this is the starting point of the plate. Okay, okay, this is the starting point. Okay, and here the starting point is at this 0, and if you put the dielectric the length of the dielectric length here, so it will be 0.762. Okay, 762. You have to give the z direction, and if you put the y length also from 1.8, so it will be nicely fit with this board like this. Okay, let's see it. Okay, so this is the rectangle. Okay, now that is rectangle 10. No, so okay, so what is the exposition is okay, 26.04. Y position should be, what is the y position? It should be 21.2. Okay, this point 21.2. Y position should be 21.2. So I will keep this z position as 0. Okay, so actually this will be if we put it to 7.62 and minus 7.62, that is also okay. No, I think that is also okay. No need to change. But anyway, I will change it. Okay, because I understood it in that way. Okay, so anyway, you can put any value here. Okay, and according to that value, you have to put the length here. Okay, so the requirement is you have to place that object in your expected location. Okay, that is the objective. Okay, okay, so I think it is okay. Now I okay apply. Where is the port? Where is the port? Not port rectangle. It is gone. Okay. So anyway, we have moved it to a wrong location. That is the problem. Okay. So I will go to the rectangle again. Okay. So this is 231. So it is there, no? It will be, so y direction is 231, 231. So I think it is there. Okay. So we can't see it if we minimize this, maybe there we can find that one. Okay, on the top of the page we can find. Okay, we no need to go to find them, we can shift it. Okay, don't worry. Okay, so I will shift it. Okay, so what is the value? 21.2, no? Y value 21.6. No, 21.2, no, this value 21.2, yeah. So it will be 21.2. So additional 3 is here, mistaken. Okay, so if I, okay, and now you can see that it is shifted here, but still it is not aligned. Okay, why it is not aligned? I think there is a problem with the coordinate. Okay, so we have to put 26.04, 21.2, and 0. This should be plus. Okay, this should be plus. Okay, now it is shifted here. So here this x y direction, no, so you can see the y direction. So this is y direction. So we have to so still the y direction length is wrong. Okay, it is -2. That is why it shifted to minus direction. We have to give it to plus 1.8, plus 1.8, because this is the started point and it should be gone to this side. Okay, so it should be 1.8 to this side, plus 1.8 to this side. So you can see that it is nicely fit again. Okay, so we have drawn a rectangle. Now we can give excitation. Okay, for that we have to select the rectangle, that is the rectangle 10. Okay, so that is the rectangle 10. Okay, I highlight it, then I assign excitation, column port, next, new line. Hmm, oh yeah. New line should be here to here. Okay, so it is defined. Okay, okay, now we next finish. So we have given another excitation, that is for port 3. Okay, that is okay. So we have to give the excitation to the last port, port 4. Okay, this one, for this one. Okay, okay, so we have to give the excitation here. So this is the ground plane and this is the microstrip. So we have to give the excitation in this way. Before that, we have to draw a rectangle from here to here. Okay, in this, like this. Okay, okay, let's see what happened. Okay, so so now we are, so now we are going to draw this rectangle here. Okay, now going to draw a rectangle here in this, like this. Okay, we are going to draw a rectangle here, like this, like this. Okay, so what is the x value? X value is -10, this point. Okay, so x value is -10. And what is the y point? So let's take y point as 21.2, that is y point. Okay, and I put x z location is 0. Okay, location is 0, and the length that is in this side. Okay, in this side length, which will be the dielectric thickness, that is 0.762 millimeter. Okay, so if I set like this, I think it is okay, and we have to set the length of the x-axis also, that will be 1.8. Okay, the port width. Okay, okay, so we will give like that. Okay, so we have rectangle 11. Okay, so the position should be -10. X position should be -10, and Y position is 21.2, 21.2. Z position we will put as 0. It is 20.1, no? 21.2, no? X direction, sorry, Y point, here, 21.2, okay. 21.2, 0. And Y size, we have to give 1 point, I think it should be in plus direction, 1.8. And the X should be, Z should be 0.762, okay. So it is nicely fit, no? So we have to give the excitation again. So we have to select the rectangle, then we assign the boundary excitation. So it should be a lump port. Okay, it should be a lump port. And next, then we have to draw the excitation line. Okay, so excitation line will be from ground plane to plus plane. It is defined. Next, finish. Okay, so we have given the excitation also, all the excitation we have given. Okay, so as usual, we will move to the XY plane. Okay. So this will be our design. Okay, this will be our design. Okay, so you can see that we have given excitation. So this is excitation 1. You can see that is small. We can see that. Okay, this is excitation 2. Okay, and this is excitation 3, and this is excitation 4. No, you can see this is excitation 4. 3 is there, 2 is there, 1 is there. Okay, so for excitation we have given. Okay, now another thing we have to do. Okay, in this case I think it is not required. Okay, because we are not doing any radiation things. Okay, for example, if we are using an antenna, we are doing a radiation. Okay, so we have to design a radiation box. Okay, so it should be if it is in the case of antenna, that radiation box should be in uh, far end big far end region. Okay, so I think if you are doing the simulation like this, I think it will be okay. I'm not sure. Okay, anyway, I will draw a radiation box for that one also, for this one also. Okay, so when if you are doing antenna things, this radiation box is very important. Okay, so radiation box is, it is a box, 3D box. Okay, so normally so this is the substrate. No, okay, so I draw a box from this here, from this end to, let's say it is around 20. Okay, and this is also from 20 millimeter. Okay, and here in this end, from here it will be also 20 millimeter. In this direction also it will be about 20 millimeter, and for the X side, so X direction also, one is 20 millimeter, and the other side also 20 millimeter. Okay, so this will be inside the box. Okay, so if I draw a box, okay, if this is our substrate section, okay, if this is our substrate section, so that this substrate is inside the box like this. Okay, I can't go 3G image very well. Okay, like this. Okay, so any distance is more than 20 millimeter. Okay, so from here to top place 20 millimeter, here to bottom place 20 millimeter, this side 20 millimeter, this side 20 millimeter. Okay, so we can easily draw that box actually. Okay, it is not we it can it, the length can be changed. Okay, it is not much affected. It is not much impact to the system design. Okay, so we can draw a box. Okay, so the boxes should be like this. Okay, okay, so this is the box. Okay, now this is the box. Okay, and I have, sorry, this is box 2. Okay, so let's take blue. Okay, and I think this is transparent. If we reduce the transparent also, it is easy. We can see the substrate inside this box. If we reduce the if you increase the transparency. Okay, if we increase the transparency, we can easily see what is inside the box. So inside the box there should be a there should be the there should be our coupler, no, substrate section. Okay, so this is okay and okay. Okay, so now you can see that you can see the transmission, the plate. So this box should be moved to this way. Okay, should be moved to this way. Okay, so this is y direction. So this is y direction. So if I start, so this is z direction. Okay, so I start z direction with -20. Okay, -20, then I put -20 length. Okay, so I think it will be then it will be cover the z direction. Okay, and also I will put -30. So the -10 in x-axis, so I will put -30 there. Okay, and here also I will put -30. Okay, so I will explain it here. Okay, so here in this direction you have -10. Okay, so I will start my box here at -30. Okay, so this is the x direction, x location, and y location I start the box. Okay, so from here I will give 30. Okay, so let's say 20. Okay, so here it is, we have 20 millimeter distance. So from here to here I have already, I also have a 20 millimeter distance from here. Okay, from here. Okay, so I will give the 20 millimeter from here, so -20 millimeter. So if I start the box here, -30, -20. Okay, so this is my x coordinate, this is my y coordinate, and z coordinate I will start from z -20, z also in -20. Okay, so that means if my substrate is here, the box will start in this direction. Okay, the z value will be 20, -20. Y value also should be -20. X value will be -30 because x we have 10 here. Okay, so I put it as -30. So we can have a 10 millimeter gap. Okay, we can have a 10 millimeter gap from here to here. Okay, so I put this is box 2. Okay, so I put so I put here -30. Okay, you can put any value. Okay, -40, -50, any value. Okay, so I put here -20. Okay, if this box is little uh, long or little large or little small, it is okay. Okay, so this value can be changed. Okay, and also I will put minus 20. Okay, and next axis I will give plus 20, plus 30, plus 30, no, 40, around 40. Okay, y-axis I will give plus 20, and z-axis I will give again plus 20. Okay, oh, it is not inside the, yeah. So what is the problem actually? So here I have given 40, 20, 20, no? Yeah, so you can see that. So I start to draw the box here, okay, and I give 20 in x-axis, not 20, 30 in x-axis. So it is up to here. Then 20 in y-axis. So it is up to here. And so I write it blue. Okay, so 20 I give and 30 I give. I start drawing the box here. Then I give the length 20, and I give 20 in z direction, and 20 in y direction, 30 in z direction. Okay, so here I give 30 in z direction. Okay, 20 in y direction and 20 in z direction. Okay, so the box will be like this, no? Okay, okay. So what we have to do? We have to give from here to here actually. So length should be, here it is 30. Okay, so from 30 to here, and it is here again 36. Okay, that means 86. Okay, so I will give another 20. That means 96, 106. Let's say it is 100. So I will give 100 here, x-axis. Okay, 100 x-axis, and y also I have to give from here to here. It is 30, around 30, and I will give another 20. So I will give 70. Okay. So here x-axis I will give 100. Okay. Y-axis I will give around 70. Okay. Z-axis I think it is okay, no? 20. Now it is somewhat okay. I think x-axis we can reduce. Okay, we can reduce something. So x-axis I will reduce about around I think 70 enough, no? Then we have a nice box. Okay, 70. Okay, so if I go this, okay, so it is yeah. So this is z direction, no? Z direction. So so here the minus 20 is this side. Okay, so the box is starting here at minus 20. Okay, and I give only length is 20. So it is up to here. Okay, then I have to give another 20 to shift it here, no? So here it is 0 to 20, and 20 to another 20, that means 40. Okay, if I give 40, it will be okay. I hope these are very simple. Okay, I hope you can understand. So if I put here this 40, I think our box will be okay. Now see, now we can, now our substrate is inside the box. Okay, so so anyway, you can draw this box in as you wish. Okay, only thing is you have to put some dimension. Okay, like this. Okay, so you can see that now it is nicely inside the box. Okay, now our design is almost finished. Okay, and for this radiation box, okay, we have to assign the material. We will assign air. Okay, so that is the practice case. Okay, Okay, so it will be here. Okay, so now we can do our simulation. Okay, so to the simulation, we have to set the frequency. Okay, so so if you have participated for the physical session, so this part will be very easy. Okay, uh, so anyway, we have to assign, we have to do analyzing. Okay, so you have to use this one. Okay, here under project manager, you have to use this analyzing tab. Okay, so we have to add the frequency. Okay, so first we have to add the design frequency. Our design frequency is 3 gigahertz. Okay, so I add solution setup. Okay, and our here we have to put our design frequency 3 gigahertz. It is okay. Okay, so now we have at the setup, analyzing setup. Okay, now to measure the S parameters, if you have used the VNA vector network analyzer, you know that this S parameters we have to measure for different frequency, and then we have to analyze. Okay, so to measure it different frequencies, like in a VNA, we have to set the sweep, frequency sweep. That means it is not a constant frequency. The frequency is changing from some value to some value. Okay, so I will put the sweep here. So right click on the setup and add frequency sweep. Okay, so so here we have to add the frequency sweep. Okay, so here it is 1 gigahertz to 10 gigahertz. Okay, so normally the requirement is our design frequency should be middle in this region. Okay, so I will use here, it is around 0.5 gigahertz to 0.5 gigahertz to 6 gigahertz, 6.5 gigahertz. I think that is enough. Okay, 6.5 gigahertz. That means this software feed the frequency to every port from 0.5 to 6.5 gigahertz. Then it measure the S parameters. Okay, so that is what we are doing. That is what we are doing. So step size, I will reduce the step size. Okay, I will reduce this as 0. Okay, so if you preview, you can see. Okay, for these frequencies. Okay, so one time this 500 megahertz frequency is sent through the port 1, port 2, port 3, port 4, and it measure this parameter. Then other time is sent 510 megahertz, and it also sent through port 1, port 2, port 3, port 4, and it measure the S parameters. And then it sent 520 megahertz through the coupler. Then it measure the S parameters. Then 540 through the coupler. Then it measure the S parameters, so on. It will do up to 6.5 gigahertz. Okay, so that is the idea. Okay, so okay. So now we have at the frequency setup, and also we have at the at the also we have at the frequency sweep. Okay, so now I think we can do the simulation. Okay, so if you no need to see this box, you can use this tab. Okay, so here you can use you can see I. Okay, so if you click this I, so here box 2 visibility, you can remove the visibility here. Okay, so now you can't see the box here. Okay, but box is there, but we can't see it. Okay, okay, so now we have to so now we should check that, so every solid line and sheet we have assigned the material or boundaries. Okay, so there should not be any unassigned material or sheet. Okay, all should be assigned. Okay, so it is already assigned, and now we can do the validation. So you can click this validation button. Okay, then it check the validation. So if any problem is there, it should be shown. Okay, here a problem is found there is an excitation. Okay, so maybe this excitation are not defined very well. Okay, it is not defined perfectly, but maybe this will be okay. Okay, so we will run this. Okay, to run this we have to push this analyze. So okay, so if I click it, so before that we have to change, we have to save our project. I will use it as blc underscore lab. Okay, then I save it. Now it is analyzing. Okay, so here you can see the progress. Okay, so it is analyzing. Okay, so I put this progress, I click this progress button. Okay, now we have to wait. Now what is this doing? Okay, so in the same way, it send that frequency sweep to this port and measure the S parameter value. Okay, actually in network analyzer it is measured in a practical way. It send the frequency actually, and it measure the received signal and the forward signal, then it measure the S parameter. But here uh, these S parameters are measured based on the Maxwell equation actually, because this software is based on Maxwell equation. Okay, so this is not this is we can get the theoretical result here. Okay, but we can see the dimensions are okay or not. Once if we have implement this before checking, okay, after implementation we can use the network analyzer and we can check. But if there is any problem, if the dimension or something need to be changed, then we have to make a new one. No? So before doing the practical implementation, physical implementation, fabrication, we can do a simulation using this kind of software and verify. Okay, so now I think simulation is stopped. Okay, now it simulate. Now you have to go this result. Okay, so click result here, I play. Okay, so here you can see that create model solution data report. Here you have to find the rectangle plot. Under that one we have S parameters. Okay, so there are variable parameters VSWR, gamma. So these S parameters are very important. Okay, actually using the S parameters we can get the idea about this component. Okay, so these things supposed to be discussed in our lab 1. Okay, so here I'm not going to discuss this. So I use all the S parameters. Okay, there should be 16 element. Okay, if you count this, there should be 16 S parameters. Okay, and so this should be in dBm. Okay, then I take a new report. Okay, so this is the X parameter analyzing. Okay, so I leave this analyzing for you. Okay, because these things we have to discuss in our lab T, how we are using S parameters to measure. Okay, so if you have attended to the lab 1, you may know this. Okay, how we are going to analyze. Okay, so I think this our design is perfect. Okay, our design is okay. Up to some level it is okay. Okay, so if I take S11, S11, so this is S11. Okay, I think it is okay somewhat. Okay, and if we put S31, if we take So I think this also okay. So at the marker minus 5.3825. Mm, okay. So anyway, I think the most important parameters are S11 and S31. Okay, S31. Yeah, S31. And you have to observe these parameter variation, and you have to come to a conclusion. Your design is okay or not. Okay, so I leave that analyzing for you. Okay, and when you are making the report, what you have to do is you have to do this. You have to do the designing according to the given data set. Okay, that data set is based on your registration number, last digit of the registration number. Okay, so you have to do the design. Okay, you have to do the calculation, and you have to do the design here. Okay, then you have to check these parameters, and you have to uh, validate your design whether it is okay or not. Okay, so that is the things you have to do. Okay, so if you have come, so this analyzing part we have explained. Okay, we have explained in our lab 1. Okay, uh, so if you have attended to that one, I think you have the idea. Okay, so please submit a report. I think you will be given around 2 weeks to submit the report. Okay, so uh, you can put this graph and your design to the report also. Then make a report, then send it to me. Okay. Okay. So we will wind up the session. I hope you get the idea how to use HFSS for to do a design. Okay. So okay. Thank you.